Okay, Dana, ready for the preparation stuff?
We are ready. We also
Okay.
are aware that many of you may have some admin restrictions or parallels or other things that you need to be concerned about. That's absolutely fine. Once again, today is for prep. We're going to try to walk through a lot of this. But hopefully by next week, you guys are all ready to go and we can jump right on board.
Okay, if you open that Notion page link that we shared and go to the first link, it's called preparation. This is what I had in mind for the whole series, all the for or whatever workshops that we're going to go through. So you don't need all of this application to install right now, but make sure for this first one that we're going to dive into Python only and just cover some of the basic Python stuff. So next session we can actually dive into playing with the Revit API. Make sure that obviously you have Revit 2020 or 2021 installed. 2020 would be better if you want to use that one. And Revit Python shell would be very helpful. The link that is on the Revit Python shell itself will take you to this page, which is the sort of like releases, and you can download this .exe installer for Revit 2020, and it should be pretty straightforward to install. It's not a very complex application. We're gonna need a Visual Studio Code as well, or whatever favorite other programming sort of like source code editor application you use. VS Code is very, very popular. You can use it with all sorts of other programming languages as well. And it's got really amazing Python support with the Python language server. So we're going to use that one if you want for this course. It really doesn't matter. You can use even a small text editor. And then make sure that you have Python 3.9 installed. Go to python.org. Python.org is the single source of truth for anything Python. Go to the downloads, and I'm on my Mac, so you'll see download for Mac in here, but you should see download for Windows. You can get that downloaded, installed on your machine, and I think we will be ready to start. The only other thing that might be helpful, I highly suggest it to everybody, sort of like to install this, especially to sort of like make it easier and work in a terminal that looks better and easier to work with, is Windows Terminal. Windows Terminal needs to get installed from the Microsoft App Store. So you kind of have to sign in with your Microsoft account, get it installed and everything. If you don't have it, you can just use the PowerShell. So in Windows, if you go, I'm going to launch my Windows and I'll show you this. But this is sort of like the Windows Terminal is the more modern terminal that Microsoft created for Windows. And it's becoming very, very popular. And it also looks good. It has like lots of like styling, editing, and all that kind of stuff. You can also say, open your start menu and say PowerShell and launch that one. Yours might have a different color, but it's pretty much just a shell. And we'll talk in detail about what shells are and everything else in future sessions. So don't be intimidated by this environment that we're working with. I'll show you what these really mean.
Ehsan, share your screen. Also, we may need Timon. 1 second.
Wait,
Let me make
I am sharing my screen.
Yeah, Timon's not brought. Thank you, Timon.
Okay. Okay, great. So yeah, so we talked about, I'm going to pull this up. We talked about having Revit, Revit Python shell, get it installed, fairly easy. And I'll show you what this actually will give you. Visual Studio Code, Python 3.9, and Windows Terminal. For the rest of the stuff, you don't really need anything else. We sort of like we'll use some of these learning resources throughout this course as we go through it. So sort of like, have that piece as the links, and I'm going to change this to this so they don't look like shortcuts and stuff or checkboxes. Yeah, so we're going to use these as the learning resources. For the first one, for anybody that sort of like this is what I suggest for anybody that wants to learn Python, that you can go to documentation, docs, Python docs, and go to Python tutorial. We're going to follow it sort of like a style that's pretty similar to what the tutorial is. So I'm hoping that, following this style, you can actually dig into the tutorials later yourself and sort of like look at the more advanced stuff if you need to. So it's sort of like this will give you a layout of like what you can follow. I think I'm going to give you a little bit of time. I know you have already these already set up. So if you want to share your screen and show everybody that you have these applications set up and stuff like that, we can switch the screens. I don't have your audio.
Do you want me to open up Revit and show that, or do you want me to open my add-ins folder?
Actually, I'll show them here. So on my Windows, I've installed Windows Terminal. This is Windows Terminal. It's going to give you access to PowerShell. This is what that PS means. I'm gonna actually make this bigger. So PS means that you're running PowerShell. I'll explain all this stuff later in the future. Don't worry about all that kind of stuff. Just learn that you are running PowerShell inside Windows Terminal. That's all it is. Normally, you want to use, if you don't have this, you can just use PowerShell, as we discussed. Make sure in whatever terminal that you have installed, when you say Python, it'll take you to, I'm going to make this one bigger again. It will take you to Python 3.9.1 that we just installed, right? And then for the Revit Python shell, I'm going to launch Revit. And for Visual Studio Code, this is Visual Studio Code. Fairly simple application. Installation is a breeze. It's not really that complex. I have a project open here, but I'm going to actually open a new clean window. Yours is going to look like this, probably in the dark mode. If you want it to be in the light mode, follow this sort of like the guides on this home screen. It says Control-Shift-P is show all commands. So if I do that and say theme, it allows you to change your swap themes to a light or a dark or something else that you want to swap to. This is how Visual Studio Code works. It gives you a sort of like a command environment, which is this. It starts with this greater than sign. And then these are the commands that you tell Visual Studio Code. You can open file very quickly, open a folder, or open something that's recent. So these are really, really good, very helpful shortcuts that you may want to get used to using. But two of the most important ones that I use as Control-Shift-P to give commands and Control-P to find a file that I want to open. These are the ones that are like super easy to set up and use and all that kind of stuff. And then on Revit side, once you launched your Revit, you should see under add-ins. I'm going to open an empty document here. Empty model. And you should see this little Revit Python shell panel with the tool under Revit. You can just click on the tool. Don't worry about the other options. It gives you a shell like this. The difference between this shell and this shell is that this is running inside Revit and it will give you access to Revit internals. That's the main difference, right? That's what we want to have this. So we want to play, once we get to a level that we want to play with the Revit API, we're going to use this Python terminal to play with that. And you can see similarities between these two Python prompts. It says Python 3.9.1 here, and in here you see Iron Python 2.7.7. We'll get into the details and nitty-gritty of like what is the difference between Iron Python and Python and stuff later. Just know that you are seeing a prompt and sort of like these three signs in here that tell you what the prompt is. And here is when you can actually start typing Python code. Same thing in here. Okay, I think this is all I had for the setup. How are you feeling? Do you think everything is good? You ready?
Yeah, I think we're ready.
Okay. Do we want to give everybody else time to get set up?
No, I don't think we don't need to. Mark is actually asking, which I had the same question, which Revit lookup do we need? And I think it actually depends on which Revit version you have, correct?
Yeah, so for the Revit lookups, let's take a look at the Revit lookup. I'm going to go here. It'll take you to the continuous integration, continuous build page that they have. And you can see that everything starts with 2021 or 2020 or 2019. Just make sure to get the most recent version for whatever version of Revit that you're using. The APIs are pretty similar. So in most cases, even if you install 2021 on 2020, it's not going to do anything crazy, but it's better to have the one that's right built for that specific version, right? And it goes as far as back as 2015. Obviously, we're not going to talk about anything that's before 2017, of course.
And also, if you go to the top and you actually click on the Revit lookup GitHub link at the top there. Oh, sorry. Yeah, that guy. It actually will tell you down at the bottom the versions. So which one is particular for each version. So that's also helpful as well. Yeah.
But you don't need this installed for this session. We'll talk about this in the next section. And I think with that, you won't need PyRevit for this series. We're going to talk about Python and Revit, and then hopefully we have some ideas about continuing with the PyRevit workshop later on. So that would be also fun to watch. Okay.
Let's jump into it. I say if we need to, we can start a little slow, but I say, yeah, let's jump right in.
Okay. Okay. I'm going to go back to the page for this course. The first thing that we want to talk about is what is a program. Understanding this theoretical concept is incredibly important, because I want you to get very comfortable looking at that script that you are writing and sort of like know exactly, not exactly, but like theoretically what is actually happening behind the scene, right? The first person that we're going to get familiar ourselves with is called Alan Turing. He's widely regarded as the father of theoretical computer science. You might know him from the movie The Imitation Game. He is the person that sort of like created an electromechanical machine to break the Enigma code of the Germans in World War II. He also created sort of like this idea of a Turing machine that we'll talk about right now, and the Turing test that you might have heard it before if you have watched the movie Ex Machina. They'll mention the Turing test in that movie. It's a test sort of like between a human and a machine, and the way sort of like that you can recognize a machine whether it's human enough or not. But it doesn't really matter to us. We want to talk about a Turing machine. Alan Turing created this sort of like idea of a machine that has a, let me see if I can find a good photo in here. Let's say Turing machine tape. Search for Turing machine tape. He created this idea of this sort of like unlimited length of tape that sort of like goes from one direction to another direction, and the machine that has a head on this tape, and it reads each instruction, and each instruction tells the program to make some changes to the concept of that tape, or move to one advance, move back, sort of like directions on what to do for the head, right? So this is sort of like the theoretical concept of what a program is. And I'm going to show you something in my video, if you want to look at in my own feed. This is a tape, a paper tape with some holes on it from a machine in 1970 something. This machine was called a PDP 11, and is made by Digital Equipment Corporation, DEC. And this is sort of like a paper tape that has a program on it. And you can see there's like a whole bunch of holes on this one. I don't know if I can get this in the right light or so. Yeah, you can see a whole bunch of holes on this. Now there's a lot of like copyright messages and stuff like that on this too. But it's that tape that we were talking about has a literal physical representation. This is how computers used to work. We would put this in a machine, and it would start from one corner, read all these instructions, and execute them depending on what that instruction was. A different variation of this are the computer cards that you might have seen before. We had like punch cards with a whole bunch of holes on them, and we would feed this into a machine, and it would read them card by card. But it's pretty much the same thing. It's like a tape that's broken into little pieces, right? So going forward, whenever we talk about program, have this concept of an insanely long tape that you're creating. That's your program. You start from somewhere and end somewhere else. In our programs, we start from the top and go to the bottom. So that's that you're writing is really the tape. And the head of the computer will read the first line, execute your instructions, second line, third line, and it goes forward like that, right? The second thing that we want to talk about in this one is the concept of algorithm. The algorithm, you know the meaning for the word. Algorithm is sort of like the steps that you follow to accomplish something, right? What I wanted to sort of like make you familiar with is the concept of flowcharts. I've put a link in here for an application that's called, it used to be called draw.io, and I think that still works, but sort of like the domain changes to something else. But this application will let you draw some like graphics and flowcharts and stuff like that here. It's a really good application, web application to get charts drawn. Go to the flowchart, and flowchart is a graphical representation of an algorithm, right? So we're going to start from a point, and we're going to go do something. And each one of these sort of like block shapes has a name. If you hover over them, you can see that's a start. That's a process. So we're going to go from here to here. We're going to start. We're going to do something. And then sometimes we have to make a decision. We're going to go from here to here and then decide based on some criteria whether we want to go left and do something else, or we're going to continue down the same path. As we're drawing this, you'd realize that it's sort of like a tree, right? This is the concept of branching. So we do something, we'll get to a point that we have to make a decision, then we branch off to another direction, or we continue down our own branch, right? So always remember that when we talk about branching, this is the concept of branching. Branching happens when you have to make a decision inside your code and go down a different way, or other. In terms of thinking about the tape, branching is sort of like an instruction that tells the head of your program to go somewhere else on that tape that you have the other instructions written, right? So it doesn't continue down the same path, but it moves the head to somewhere else and continues the instruction from somewhere else. We also have a concept that we call it loops, right? So we could, in our algorithm, you can tell the head of the program, the head of the computer that's reading our program, to move back to somewhere else and maybe repeat a process over and over and over again, right? This is how we create a loop in our program. So keep that in mind. If you got anything from this conversation, remember branching, the sort of like the flow of program as a tape, and the concept of loops, right? So sometimes we have to have a condition, we have to make a decision, we might go back in time in our program to do something else, not necessarily in time, but in our program. That's sort of like everything that we wanted to talk about to get started actually writing some Python code.
Sounds good to me.
Yeah, if you have any questions right now, let's jump in and respond to the questions. I've put all the links for all these applications, so we should be good to go. Okay, let's dive in with Python. The first thing about Python that we want to play with is called the Python interpreter. That's the Python application, the program that we deal with. We'll get into a lot more detail about how this program works and all that kind of stuff later, right? But just remember that when it's in our terminal, we say Python. I'm on Mac, so I'm going to say Python 3 because Mac also has Python 2 built into the sort of like the operating system. So I don't want to launch that one. When you say this, you launch the Python as an application. There are two ways we can actually interact with Python. Python interpreter, which is what you're seeing on the screen, meaning that it gives you some information about what Python you're running, and then it gives you this little thing that's called a prompt, right? In front of this, anywhere you see this with Python, that's a prompt. In front of this, you can type Python code and interact with Python that way. And then Python will interpret your commands and it will execute them one by one. So instead of writing a program beforehand and just feeding it to Python, we'll actually give Python instruction by instruction and we go from there, right? We're going to play with this a little so we get comfortable with the concept of each instruction. And then we'll try to put more instruction together to kind of like, start playing with all of that. Let me look at my time just to make sure that I have time under control. Okay. So interpreter. This is what the Python interpreter is running inside your terminal. Don't worry about understanding exactly how these things work. Again, I've done this before. I've gone into a lot more detail about this, about how these processes work, and then kind of confuse the person who's learning. Just focus yourself on what we're writing on the Python and the Python interpreter. Now, a lot of times Python interpreter feels like a calculator, right? So if I type exit with parentheses in front of it, sort of like a mathematical function, right? Remember those fx or something like that in mathematics? This is looks like a function. It doesn't have any value inside the parentheses. We're going to say exit, and we're going to go back to our prompt. We left the Python interpreter. I'm going to go back inside it again. You're back inside the interpreter again. So you can see if you have the terminal available to you, which all the operating systems have, accessing Python is actually super easy. You can just open it and type Python 3 and get into Python. So a lot of people actually use this as a calculator. Let's play with some of the data types in here. I'm going to actually show you some basic mathematics. 1 plus 2.
So I can do the same thing that you're doing in the Windows terminal.
Yeah, absolutely. It's the exact same thing.
Just on the silly Mac version of it.
Yes. Yes.
Okay.
We'll talk in length about that silly comment. So like I typed 1 plus 2 multiplied by 1200. If I hit enter, it means that enter the statement and the command that I just gave it to Python. Are you showing your screen, Dana?
I'm trying to.
Okay. That's fine.
There we go. Okay, so what are we doing here?
Yeah, let me actually.
1 plus 2?
Yeah, 1 plus 2 multiply.
Three.
Yeah, you get 3. Try something else. Oh, actually, you're in your PowerShell. You haven't typed. See that prompt? It says PS, see users, Dana de Filippi. That's your terminal prompt. You have to type Python. Okay, now
But
you're
it's still doing the math. It doesn't apparently need Python to do the math in Windows.
PowerShell. That's a feature of PowerShell. It's not Python. Don't worry about that part.
Because Windows is better?
No.
Oh, okay.
So yeah, try something else. Try something that has multiplication in it.
We also warned you guys this would be banter between friends.
Yeah. Try something that has multiplication in it, and for multiplication you have to use the asterisk. Yeah, perfect. There you go. Try something that has. There you go. That's perfect also. So you can use it for like lengthier mathematics here as well. So you can see Python sort of like interprets what you're typing. That doesn't work, obviously.
But parentheses is a mathematical function. You said it yourself.
No, it's not. Well, you have to put a multiplication right after or something like that. Right?
Don't you remember, please excuse my dear Aunt Sally?
I don't know what that is.
It's parentheses, exponents. Please excuse my multiplication. It's order of operations.
Okay, here's what's important. Mathematical notation is different from what we actually use in programming. A lot of times in programming, we're limited to a set of characters, so you can't use the exact mathematical notations that you use in mathematics, right? So for example, say 2 multiply 3, for example. This is power function in Python. So this is how you add take something to an exponent. 2 to exponent to 3.
Got it.
Got it? So the concept that's really important here is that some of these mathematical notations are actually different, just like the multiplication sign that is an asterisk instead of like a cross, right? So we use something else to represent that kind of action that we want. So just to show you, you can use Python as a fairly decent sort of like calculator. Now, once we talk about modules and stuff like that, I can show you a lot of more mathematical functions that are actually available to you. Like, for example, if you want to calculate the cosine of something, all that kind of stuff, you can still use Python for that kind of stuff. We just have to add these functionalities every time we kind of need them, because Python doesn't exactly know what you want to do. It's a general purpose programming language, so it gives you this ability so you can add stuff to it if you need to.
I really hope I don't need to do cosine in Python, but that's neither here nor there.
Yeah, okay. So here's what's important here right now. We want to talk about and just settle this going forward, because there's a lot of confusion and questions about this when you're learning a new program. It's the difference between a statement and an expression. What you wrote right now on the screen, in front of your prompt, I'm actually going to share my screen again if you don't mind. Do you see my screen?
Yes.
Okay, so like this that I wrote is called an expression. Why? Because when Python looks at this, it says 1 plus 2 equals 3, and the result is blah, blah, blah. Now, it doesn't exactly do this, and I'll explain you why. But the point that I'm trying to make is that when it looks at all these values, it sort of like reduces all of them into one value. So the result of this, what we wrote, is a value that gets replaced with what we wrote there. Does that make sense?
Say it one more time.
So the result of this, like if we say 1 plus, I don't know, whatever, 1200, it does the calculation. And in the program, it actually replaces that with the result of that calculation.
Okay.
Right? Does that make sense?
I mean, it's reporting it. It's outputting it in the next line.
Well, it's outputting it right now, but I'll get to it once we sort of like get into more details of it. But basically, when Python is looking at this, it's doing the calculation for you, reporting it here because we're going sort of like line by line in an application. But when you have a bigger program, when you do this, it reads these little pieces and replaces it with the result of that computation. This is called an expression. You write something, it results in a value, right? Now, let me show you a statement. You can say print, and then say, hello, world. And then it prints the value that you put in front of the print function, right? This is called a statement. because what you do results in an action. The sort of like that line that you wrote does something. It's
what would
just
it do
not.
if you didn't have quotations?
Well, we'll get to all of that stuff once we talk about data types and stuff like that.
Like
but just
string
know
versus
that,
numbers.
yeah, the difference between this little thing that we wrote and this little thing that we wrote. Now we're going to combine these two and say, hey, what if we do this? See, so Python calculated this expression piece and it put 2401 in there. And then it printed it because that's what we told it to do. Does that make sense?
Yep.
So you got to start. What I want to convey here is that once you're starting writing programs, you got to start thinking about these little pieces in each one of your lines of your application. These little pieces are going to get combined together and sort of like for Python to be able to understand what's going to do. So it interprets these things. Python interpreter, right? It interprets these little pieces, combines them into different pieces, put them together. The ones that need to result in a sort of like get calculated into a value, it'll do that, and then feed these into the other functions and all that kind of stuff, and it goes forward line by line. Does that make any sense?
Yes.
Okay, and we see plenty of examples of this as we go forward. Just sort of like know the difference that some stuff are statements, some stuff are expressions. You don't really have to deal with this in normal programming whatnot. It's all going to come natural to you once you get into it and once you play with it a little bit. Just know when you're reading documentation somewhere else about a different program and whatnot, these are sort of like some of the basic terminologies that you want to be familiar with. One other thing that we're going to talk about is this. 1 plus 2 multiplied by 10. What's the result of this mathematics, this calculation?
Well, there's a little bit of chatter in the chat about that, but I mean, following the order of operations, it should be 21.
Okay, what is the order of operation?
It's parentheses, exponents,
there are
multiply,
no
divide. Okay.
Okay. So this is the other thing. For a programming language to be able to process these efficiently and sort of like understand what the hell is going on, it needs to prioritize things over others. So it knows which one of them needs to be calculated first. The convention is called operator precedence. And we're gonna do a search for Python.
It's kind of confusing that it doesn't follow the mathematical order of operations.
Yeah, not necessarily.
Sure, we'll get there.
Yes. This is a convention that's sort of like C as a programming language kind of set up, I think. I'm not 100% sure about this, but a lot of other programming languages follow the same thing because as you get moved between different programming languages, they all need to do the same. You can change this by adding parentheses, right? So if I do this now, I'll change that order of calculation. This is what parentheses do in most of the programming languages. They separate a piece and tell the programming language to calculate this one first. Right?
Okay, and that is even more confusing with the mathematical order of operations.
Why?
Because once again, parentheses is a mathematical function. Like in math, like if you were doing calculus, it's parentheses, exponents, multiply, divide, add, subtract.
Yeah, well, this is slightly different. So rewire the meaning of parentheses for yourself as we'll get to that part. We'll get to that usage. But for standard mathematics statements, expressions like this, know that when you do a parentheses like this, you're going to change the order of these operations that's happening.
Okay.
We're not getting part of the reason that we're moving so fast about this stuff because we don't want to get into too much detail about these things.
It's just worth noting.
Yeah, exactly. You're going to use this so many times during the programming that all of this is going to be all natural to you.
It's click.
At some point, your eyes are going to sort of like understand this, that the multiplication is happening before the addition, just subconsciously, right? The link is also here if you want to find it on Python. There's like a bazillion different links. Just search for Python operator precedence or any other language operator precedence, and you can find them. The operator that we're referring to is this, and that's called a binary operator. Why? Because it operates on two different values on either side, left and right, right? It's called a binary operator. Some of the operators are unary operators. They only operate on one value, and we'll get to those later. How are you feeling? Is it good?
Yeah.
Okay. Okay, so right now we're going to talk about data types really quickly in Python. For the programming language to be able to store the values that we're giving it to the programming, to the sort of like the programming language, to the environment, it needs to know kind of what the data type is, right? So in Python, Python is super flexible about these data types. It has type definitions, but it doesn't have a lot of the sort of like limitations that other programming languages have. And that's one of the most attractive things about Python. Python is very flexible, right? We're going to store the result of our calculation in something that we call it a variable, right? Just like in mathematics that you would say x equal 1, right? You can just say that in Python exactly. Nothing happens. What did happen? Python took the value of 1 and placed it inside a variable named x, right? So
it
from
just
now
stores that in its memory, and now x will now be referred to as 1.
Exactly. What exactly is happening behind the scene is that somewhere this 1 is stored somewhere on the memory of your machine, and that x name is pointing to that location. But we don't deal with this sort of like this complexities and the wirings and all that kind of stuff. All we need to know is that the value of x is 1. And if we just ask Python to
It reminds me of like when you were in grade school and you and your friends would come up with the secret language. Did you ever do that? You know, and it was like A was this character, and you know, you'd have to like go back and break out the text
for my language. Yeah.
That's what it reminds me of, right? Okay, so we're on the same page. Awesome.
Okay, so here it is. The variable x has some value in it. Now, sometimes we want to know what the type of this value is. Do we have a string in it? And we get to what strings are, like the name Ehsan, or do we have a number in it? And if we have a number in it, what kind of a number is it? Is it a fractional number, or is it like a round whole integer number? Like what kind of stuff are we dealing with? To do that, we use the type built-in function. We'll get to what functions are and what built-in functions are later. Just know that this is just something like print that we used before. Its name is type, and its purpose is to give you what the type of that variable is that we have stored in there.
Okay, and because you already told x to be a 1, it knows that it's an integer.
Yeah, exactly. So it'll tell you, don't worry about these little things and the class and all that kind of stuff. We want to read what's inside these two quotation marks, right? The single quotation marks. And it tells you it's an integer. Int is a known data type to Python. I can say int, and it would print that for me. If I say print int, it's like a variable that's been defined before. We don't call it a variable; it's a type, but it's one of those built-in stuff in Python. Now, if I say y equals Dana, and then say type y, it tells me it's an str. It's a string. String is this. Why do we call it string? Because it's a string of characters that are set sort of like right after each other. We can create strings in Python in two different ways, with single quotations, or with double quotations. I can go back, if I click up, I can go back to the previous lines that I've written, and I can rewrite them, right? So y1 is Dana, y2 is Dana. You can see that Python, although we created y2 with a double quotation, Python really doesn't care. As far as Python cares, both of these are strings. That's up to you when you want to use single quotation or double quotation.
Do you find it there's a, okay, yeah. What's your, like, do you find there's a standard of what people follow?
Not necessarily. My personal preference is that I use single quotations for anything that's internal to the application, like log messages, values that I want to store, all that kind of stuff, and double quotations for everything that's user-facing. So if I want to print a message to somebody else, I put it in a double quotation. This way I can use regular expressions to find this stuff in my program later on and all that kind of stuff. And when I'm reading, when I'm reading it, this feels more like I need to be careful about what I'm typing there, because this is what the human will see, right? Okay. It's just my personal preference. You can do whatever you want to do. Python doesn't really care. As you can see, like, it prints everything with a single quotation. It doesn't care about what you're doing, right? So that's the string data type. We're going to talk about one more data type in here. Let's say XYZ equals 1.2.
A number.
It's a floating, yeah, it's a floating point number. And we'll get into a little bit, at the end of this session, I'll explain a little bit about these
versus then a double.
No, don't worry about the double. Double is a term that comes from C. Don't worry about the double in Python.
Okay.
Float, everything, all these like little things with the dot in the middle, numbers and fractions and stuff like that, we're gonna call them float numbers, right?
Okay.
So it's a float. Dealing with these numbers is a whole branch of computer science. Like there's been mistakes that missiles have gone into different directions because of the resolution of the floating point value and all that kind of stuff. So, you know, we'll talk about these stuff. We'll talk about floats at sort of like at a more advanced level some other time. But just you know that this is the type of the value that stores your fractional stuff, right? So the three main data types that we talked about, these three. There is this infamous dot that you have seen, I'm sure, in many different other places, that when you type something, like you say Dana, and you say dot name, it'll refer to a property of that main one, which is Dana, right? So I'm sure you have seen this in other places too. If you haven't, let's get familiar with this concept of the dot. I'm gonna say Dana here.
Well, give me a Revit example, like wall dot.
That's too soon. That's too soon. Well, I'll give you a conceptual Revit example. Look at this. Like actually, that's a good way to look at it. You're right. Let's do a conceptual Revit example. Let's say I have a wall, and I want the volume of that wall.
Okay.
So the thing that comes after the dot is a property of what sort of like came before the dot.
Yes.
Right? It belongs to that. It doesn't necessarily always hold a value, and I'll show you in an example. It could be something else, but it belongs to that thing that just came before it, right? And we could go nested. Like we can say wall type, wall, then volume, right? We could go as much as we want in this, depending on the data types that we're dealing with. An example of this is this. Dot.
Okay.
So I had Dana as a value, then I used a dot and reached into Dana and used one of its helper functions. The purpose of this function is to load that string, right?
Okay.
So if it was Dana, it would be that.
So okay.
If it was longer, what it does, it lowers that string and returns the value to you.
Is this also how you would do mathematical functions? I'm probably getting ahead of myself, but like you could say 3 dot math ceiling or something.
3, what is it? Well, yeah, it depends.
Like 3.45 dot math ceiling.
So this is where you put this. Like you could say, let's say math dot ceiling and give it a number, or you could say, I'm going to just type it on the same line, that number dot ceiling, right?
Okay.
There's a whole sort of like field of computer science about like how should we create these functions? Do we create them as property of that 23, or we put them somewhere else and make the user call them that way and stuff like that, right? We'll get all to all the details of this. I'm gonna just get your hands dirty with accessing, reaching into these types that we have and using their sort of like their utility functions and all that kind of stuff. Right? Get familiar with this right now, and I'll show you more examples of this later. The concept that I'm trying to carry is that string that we see is behind the screens more than just that string. That type str that we talked about, that Python showed us for that type, has a whole bunch of other stuff attached to it that are utilities and help us like do stuff like that, right?
Got it.
So like another case would be, I think, title case. Yeah. So you could use, like if it was Dana, you can actually change it to title case by calling .title on it. And this is specific to Python and these data types. And you have to go into.
You know, there's no native Dynamo node for title case.
Yeah, exactly. So imagine create, like I'm gonna actually launch my thing in here. And let's what now we use now we know how to change a string to a title case, so we're just going to use it. Anyway, so just the purpose of this is to show you these stuff, right? These stuff that comes after the dot. And we're going to see a whole bunch of complex type of this, and I'll show you at some point how you can actually create and add these stuff to your own data types, right? While I'm waiting for, let's do a empty model and let's launch Dynamo.
It looks like it was noted in the chat that you're using the up and down keys to recall lines.
Oh yeah, so every time you see I fill in this line really quickly, it's like I'm using the up and down on the interpreter. That's a property of the interpreter. If you say up, it goes back up to the history of what you have typed.
Mm-hmm.
Right?
And yeah, it looks like it's pretty easy to scroll through the different lines.
Yeah. So let's say I'm going to throw a Python script in here.
Oh,
right?
I'm excited. Okay.
And we're going to do, how do you path a string in Dynamo? How do you create a string? Is it watch?
It's just string.
String?
Or
okay.
a code block. Double click on the field.
Okay, let's say we want to call this, how do you go? Okay, edit. We're going to take the input. We're going to say output. And we're going to use our, let's say, lower or title case, right? We're going to run it. We're going to pass this to this. And then we're going to use a watch. What is it? How do you look at it? Is it watch?
Mm-hmm.
Sorry, I'm not an advanced Dynamo user.
I love it. I like knowing something better than you.
Okay, so
feels
this,
like it's way too rare.
double click the what?
Below the title. If you double click on the gray portion, like the dark gray portion, it actually updates the name of the node. Rather, if you want to say not to say Python, but if you double click below the title, like below the input and output,
okay,
that's how you edit.
How do you tell Dynamo to not use this as a list? Oh yeah, oh my God, that's why you should use Rhino inside of it. I'm gonna use.
Oh, they
Rhino
can't hear Timon. Also, just so you know, Timon is talking to us in the background for those.
Okay, so we're gonna grab because Dynamo passes everything as a list, I guess. Okay, so see, we had Dana as a string, and when we use these kind of stuff, they kind of like automate that sort of like data creation and stuff like that for us. We passed it to this. God damn it. We used that thing that we got. We applied the lower function on it, just like what we learned, and we passed it. We assigned it to the output variable. This picked it up again, and you see the value right here. Easy peasy, right?
Yeah, super easy.
Okay, so let's talk about more data structures. Let's talk about lists. List of things. These three things that we talked about right now, we can make a list of them, right? So let's call it the list A. And you can see that instead of typing list A or list A, I'm typing list A. This is a convention in Python described in Python PEP 8, right? It's Python enhancement proposals. That's how Python organization actually introduces new stuff to Python. That's why they're called PEPs, and there's a bazillion of them. PEP 8 was a very famous one, style guide for Python code. It's not required, it's just a style guide. If you follow this, other Python programmers will have an easier time reading your program. And this is called a snake case, because like you can add more stuff to this, like that, and it's all the same variable, right? It's called a snake case because it goes like.
What do you mean same variable?
So that's remember we said like x equal 1, right? I can say Dana A equals Dana Z Dana A equals 12, and Dana A is the name of my variable.
Okay.
Right. So anything that came before this, that's the name.
So
Python
all those. Okay.
Underscores or even numbers, like as we used y2 in the name of the variable, right? This is called a snake case. It's very popular in Python. So sort of like it has this, gives you a visual space between the different pieces. So if you have a function, you want to say get elements, you would say get elements, Like you would name it like that, right?
I usually use camel case. Like I would
Well,
use get with an
do-
uppercase E for elements with no
Do
space.
whatever you want to do. I'm just saying that, you know, Python's pip8 will suggest using.
So that's like, you probably should do this. This is like the accepted way.
I mean, well, Python doesn't care. Python works either way. It's just other people have an easier time reading it. Or maybe if you're coming from C#, you'll have an easier time reading that one. It depends like who your audience is and who you're creating for. I just want to know that this thing exists.
So
Create
use
Python
snake case based off of the pip8. Got it.
Okay, so we're going to create our first list. We're going to call it A, and it's going to be a list of, I don't know, let's say Revit categories. Walls, category names really, doors, floors.
So why didn't you call it list A? Why just A?
I don't know. I'll just give it a name. It doesn't really matter. The name of the variable should be very descriptive. Let's say.
But as soon as you put in the, what are those? The little box guys. What are those called? It's getting late. Tim, and you're muted. Well, what as soon as you put in the brackets, right? The brackets, I think. Okay, Timon's nodding.
For the list.
Brackets, then it's a list.
Yeah,
okay.
Exactly. You have a bracket, open bracket, close bracket, and you separate the items by a comma. This is.
And that's the same in a code block in Dynamo. That's how we would create a list in a code block.
Oh yeah, that's inside of that code block. You write Python.
Yeah.
So the same rules apply, right?
Yeah. Okay.
Oh yeah.
Code blocks are different than Python, but that's the same principle.
Okay, yeah, you guys know Python. I'm gonna launch my Rhino inside Revit.
Get out of here! Get out of here!
Get out of here! I don't know Dynamo. So anyway,
that's the next session. We're gonna have a Dana teaches Ehsan workshop. How about that?
It works. See that grasshopper? Anyway, so they're separated by a comma. You can't use anything else. It's comma, right? Don't use dot this like semicolons or anything else.
And for numbers, you would need the quotations.
Between the items that you're putting in the list. In this case, I'm putting 4 different strings. I might want to like add a number in here.
Perfect. Right? Okay.
So any item will be separated by this. In this space that I'm putting here, that's a pip8 convention.
Okay.
You don't have to.
You don't have to, but it's just.
Python
give it some breathing room.
Yeah, Python doesn't care about any of these spaces that you put in between things. Like it doesn't need those spaces to understand what's going on, right? We just put it because it makes it more readable, and that's one of the goals of Python, to be more readable, right? Okay, so I just created a list and assigned it to this variable, placed it inside this variable. If I tell Python what's inside this, it'll return me, and see everything is single quotation again because Python doesn't care, right?
But it still reports the spaces.
What is it?
It
follows its own pip8 thing.
Okay.
Right? It wants to make
sure that
you as a human being can read this very easily. Right?
Okay. That makes perfect sense. I like it.
So we're going to talk about, when we're talking about lists, let's actually talk about, let's talk about sets and dictionaries really quickly.
You could do, if just going back, you could do a list of Z, Y, 2, like, of all of the variables that you've already set.
Oh yeah,
correct?
let's create B, X, Y, Y1, and Y2, right? It's gonna print the values, obviously, right? Because those names are pointing to something.
Right.
We're not putting the names.
You've already defined those variables.
Exactly.
Therefore,
we're not
Python
putting the names inside the thing. We're putting the values. Yeah. Okay. So what happens if I go and say Y1 equals I don't know, something else like Dana caps? See, I changed the value of the content of Y1, but it didn't change the content of the list.
Still using
we're putting the values there. Yeah, because we're putting the values.
I'm going to use the first one called.
Well, yeah, it's sort of like it takes the value of Y1, place it inside this, just like we wrote it here, right? And then creates a list out of the values, not the actual variables, right? These things always point to something, point to a value, or something else that we will discuss later, something more complex than a value. So that's a list. List is a list of stuff, right? I can say A equals 1, 1, 1, 1, 1, 1. It doesn't care. Like I've got 5 ones in this list, right? But there's another one that's called a set. Let's do this in B.
Little breathing room.
Okay. How's that?
It looks like we're pretty good. So we've gone over data types.
Yeah.
We've done strings, numbers, or not numbers, floats, strings, floats, integers. We didn't do any other. We did some math.
Yeah, we did some math. We talked about lists. We talked about naming of the variables, the snake case. We talked about pip8, every question that you have. A lot of stuff, like if you're using Visual Studio Code and you have an automatic Python code formatter that formats your Python code for you, like there's one that's very famous that's called Black. It automatically formats the code. These are the sort of like, they follow the pip8 conventions. You can actually, some of them are configurable, so you can tell them like what kind of convention you want to follow. But generally pip8 is very, very popular, so you see a lot of code written in that way.
We also talked about branch, the direction or the flow of info.
Yeah, we talked about
looping back.
About algorithms. We talked about algorithms, branching, and then what else?
Operator precedence.
No, inside the algorithm, we talked about branching and then going back and doing loops, right? Yeah. So branching and loops, remember those. So we're going to continue to talk about sets. Instead of using the sort of like square brackets, I'm using a curly bracket this time, right? And I'm putting 3 ones in this. But when I actually read the value, it only gives me 1 1, right? Let's put 3 ones, 2 twos, and a 3 and another 1. And then look at the value again. Set is just like the set in mathematics. You know, it can only contain a value 1 time, right? So if you have multiple of them, it'll collapse all of them to 1. It's a great way to make sure that as you're adding stuff to a list later, to a set, basically, there is only
like listing unique.
Yeah. So if you ended up adding 5 ones to a series, to a set, you're sure that that one is represented only 1 time in that thing, right? That's the difference between a list and a set. Pretty much the only difference between the two of them, right? Set, a list, you can just keep adding to stuff to it. It doesn't care. Set guarantees that there's only 1 instance of that thing, right? Okay. There's this other thing. We want to talk about how we can reference each individual item inside the list or a set, right? I can say Revit categories, and I'm going to use the same notation that we had for the brackets, and this is called indexing. I'm going to index inside of that collection of things and say, give me the first one, and it would return me the first one. Give me the second one. Give me the third one. Give me the fourth one. Index out of range. There are no 4 items in there. I think we changed this into, yeah, there are no 5 items in. Oh yeah, I missed it. Sorry. I was expecting 5 lines in here, but I missed 2. Okay, so 2 is there, 3 is there, 4 is not there. Now you notice that we count things starting from 0 in computer science. We don't count from 1. The first of everything is 0. It's index, right? The second one is 1. So when we say ask Python, how many things are in this thing? We're using a new built-in function called len that calculates the length of something, and it tells me there are 4 things in this, right? So I know that I have to count from 0 to 3. Got it? Make sense?
Yeah.
Okay, but the problem is that you can do the same thing with sets too, if I'm not wrong. No, you can't do the same thing with sets. I was wrong. Sets are, we'll talk about sets in a little more detail. I confused you right now, myself. But this is very inconvenient. Let's say, like I have this in here, and when somebody else is reading my code and it says like Revit categories 0, they're like, okay, so what is 0 in here, right? Let's say I have sort of like I want to store your information, your name and family name, right? I'm gonna say like Dana equals, her name is Dana, and her family name is De Filippi, and I'm going to store that in the list because like I want to store your name and family name in one place. And then I can say Dana 0 and then say Dana 1. But it's not very convenient. It's just 0 and 1 doesn't represent those two things that are referred to. One of the great data structures in Python that we use is called a dictionary, right? So instead of creating data like this, I'm going to use the curly brackets. It's a little similar to sets. I probably should not have mentioned sets at this point because it might have confused you, but we're going to go with it.
But no, dictionaries are used in Dynamo pretty frequently. I mean, it's a little bit more of an advanced idea, but it definitely, like I'm sure you're going to say, it cuts down on the amount of computing necessary.
Yeah. So instead of doing that, I'm going to create Dana like this. We still have the Philippi and Dana, but I'm going to put this thing in front of it that's called a key, right? This is a value. This is a key. And we have a series of sets of keys and values, right? The thing that separates the keys and values from each other is the colon. The thing that separates the key value pairs from each other is that same comma that you had seen before. So we say name is Dana, family is the Philippi. And we put a string in here, and you see that I've used single quotation here and double quotation there. That's just my convention, right? You could use whatever you want. We're using a string of name as the key and a string of Dana as the value. String of name as the key, string of Dana as the value. Now, if I want to refer to your name, I can say, give me the name. It's like you're kind of like naming each one of these items that are inside that set, that collection. Does that make sense? Mm-hmm. And if I say Dana, it'll print that for me. See, it's like it's printing everything with a single quotation. It doesn't care again, right? But you can see that there are two key pair values in here. Key value pairs in here. Key, value, key, value.
So what would you call the expression, or what would you call that before the equals, like with the lowercase d, Dana? Like you're defining the name of the dictionary.
That's the name of the variable that holds all this dictionary inside it. Its type is a dict. It's a dictionary. Okay. Just like when we store the value.
You're just naming the dictionary.
Yeah, exactly. Okay. Just like
and then the dictionary name has the variables inside that are defined.
Yeah.
Got it.
Just like we stored the value of 1 inside a variable, we can store something that's far more complex, like a dictionary inside another value, right? Let's, instead of like using Dana, using just, let's say, I don't know, friend. She's my friend. And then I'm going to say, what's my friend's name? It's Dana. What's her family? It's the Philippi, right? So now I can have another friend. Like if this was friend 1, I can have friend 2 and change these two to something else. Did I type it correctly, Timo? Two else. And then I can say friend 2 name and friend 2 family. So I created 2 different dictionaries. But you can see, like, if I'm going into a program, like, this is very readable, right? Like, as I'm reading in my program, I can understand, hey, like, what is the name of the friend? What is the family of the friend? It's better than, like, doing Dana friend 0, friend 1, right?
Right.
So you're going to play with dictionaries a lot as we go forward to it. I'm showing you this stuff so your eyes get familiar with this, sort of like looking at this complex line with quotation marks and curly brackets and all that kind of stuff, and sort of like getting to idea that each one of these stuff are going to pair up together into little pieces that we're going to put together to make something that's more complex. They're like little bricks of different kinds that we're going to put together to make something that's more complex. Get it? And we're going to use this all a lot going forward. I think we're done sort of like with the data side, and you shoot me any question that you have. We'll start writing our first Python program.
No, let's do it. So okay. Like with a Python node in Dynamo?
No, actually we're not gonna use Dynamo right now. We're gonna use a standard Python script that we're gonna run on Python on our machine. The main point here is that you see I'm showing you stuff in macOS and you're playing with the exact same thing with Windows. This is called portability. Python code is portable. means that the same code that I wrote here, you type it on a different machine and it does exactly the same thing, right? The Python application that's made for macOS and the one that's made for Windows are designed so they do the exact same thing with the language, right? The Python interpreter. So we want to move in this sort of like session, we want to move beyond the concept of Python as something that we use inside of Rhino or Dynamo or Revit or anything else. Just know that Python is a general purpose programming language. You can use it to do anything else you want. It also gets embedded into a lot of different applications like Blender, like Revit, like Rhino, like a whole lot of applications as a very popular scripting language, right? We're gonna sort of like focus on using it in Revit from now on, but just to get you familiar with this concept, we're gonna use our first program. So I'm gonna exit from the Python interpreter because at some point we want to write a program somewhere and store it and then tell Python to execute it. Every time we want to tell the computers to do something, we can't jump into the interpreter and start typing up commands and stuff, right? So we're going to exit from here. I'm going to clear my screen. I think you can use the same thing in PowerShell to clear your screen.
What did you
do? Clear, just like clear.
Just type in clear.
Yeah. And let's open up your favorite code editing application, whatever that is, Notepad++, VS Code, Notepad, Nano, Vim, anything else that your Emacs, whatever that you guys are using to do anything, your other programming stuff. But let's start a new file in VS Code and save it at a location of your choosing. And let's call it first. Actually, inside, I think I created Python workshop. But let's call it first.py. And we're going to store that way. Let me know when you're good.
Okay.
You have installed the macOS system. Yeah, sure. Don't care. Go away. Okay. Okay, great. So one thing about files and their extensions. So there's a file name, the first, and there's a separator, which is the dot, and there's a py as the extension, right? Operating systems, like to create a file in any operating system, you don't really need an extension. Extension is not a required piece of the file name, right? You can have a file with no extensions. It's a convention, very, very, very popular convention to add something after the dot to a file name to denote what's the content of that file, right? So the operating system can show you a little icon that this is the file, this is a Revit file, that's a PDF, that's a something else. And I'm gonna move you here so I can see your face. Sort of like PDF, Revit, Python, anything else. And when you double click on it, it actually opens it with the relevant application. So when you double click on PDF, it opens the PDF editor, right? But you don't have to. Just know that in your back of your mind that you don't have to assign a extension to anything. An extension is only the one that comes after the last dot, right? So you can't have an extension in the middle of the thing after a dot. No, if you can have 5 dots in the name, but the one that comes after the last dot is the extension. Now, building on top of this concept, changing the extension doesn't change the content. So if I go and grab one of your Revit files and rename the .rvt to .py, it's not going to turn it into a Python stuff. It's not going to delete the content of that file. If you rename it back to .rvt, you can still open it with Revit because Revit is going to read the contents of the file, right? So separate the naming and the extension from what we put inside the file. Inside this, we're going to use print hello world. And immediately you see, oh, this is so much nicer. Why? Because I don't care. Actually, let's make this one bigger. Because we have something that's called syntax highlighting. So the environment, which is Visual Studio Code that we're writing our program in,
and Visual Studio.
In yours, it's not doing that. Did you?
Oh wait, no, maybe it's because I didn't change my extension to .py.
Yeah, do that. Okay. That's how Visual Studio Code recognizes this as a Python file and starts the sort of like the color, the syntax highlighting, and that little Python icon in the corner.
Did it.
Okay. So immediately you see why people use IDEs, integrated development environments. That's what a Visual Studio or Visual Studio Code or something like that, or like PyCharm is. They give you a lot more functionality around the job, the programming thing that you want to do. One of the nicest thing they do is that they color code everything in your program so you can read it easier. It doesn't change the function. It just makes it easier for you to read, right? So if I do this, I can see that that's a string. But if let's say I forget to type this at the end, or like this here. Let's type this at the end and not here. You can see that the hello world doesn't change to green. And that sort of like shows you that, hey, you've kind of done a syntax mistake in here, right? Sure. This is supposed to be a string, but you didn't. So it also helps, this color coding also helps you catch syntax errors in what you're writing, right? We're going to write this and say save. Don't forget about this kind of stuff. Now we're going to run this in Python. Now, instead of using the Python interpreter this time, I'm going to right click on this tab and say copy path. And I'm going to type Python 3 with a space, and I'm going to put the path in front of it. Yours is going to look slightly different because I'm using fish shell here on macOS. You're using PowerShell inside Windows Terminal, right? Oh. I think this is the one. Oh, this, yeah, of course, this VS Code doesn't care about that kind of stuff.
So you're just putting in Python and then the extension, the file extension.
Well, path. I'm giving you the full path of the file,
yeah, the full
whatever
path.
that sits on your machine. My path looks differently from you because I'm a Unix-based operating system, so the pathing is slightly different. You can see it uses / as separators, and that's why web uses / as separators, because it's built on this sort of like concept of the Unix operating system. Windows is slightly different. Everything is sort of like backward slashes, and you might have to put double quotations around this whole path to make it work. Let's do it here too. I'm going to create one here. Type print hello world. I'm going to save this on my desktop, let's say first.py. And then I'm going to put this in front of Python, copy path, and put it here. Got it?
I think so. Okay.
Did you get it?
So
does it work?
I'm in the Windows PowerShell. Yeah, I type in Python. I get my little Python line, and then I type in.
You don't enter.
Oh,
see?
Okay.
I don't enter.
All right.
Space, and then you put the path in front.
How do I clear it again?
Just type clear.
It doesn't work.
So do a Control-C like this.
Oops. It says interrupt, keyboard interrupt. Let's see.
Show me your screen. Okay, you have to exit. You see that those three greater than signs? That's your.
That means I'm still in Python.
Well, it tells you right under it. Use exit with the parentheses or Control-Z+. So exit with the parentheses. Okay, great. Now you're back in your.
So now I do Python
space.
And then
you don't need that slash at the. You don't need the wire at the slashes. Yeah, get rid of that.
I needed to put the name of the file.
Just put Python and then copy it. What is
that's the folder?
Okay. First.py. Okay, so this is not going to work because of the pathing in Windows. So go back one up. Just hit up on your key. Okay, now add double quotation at the ends of these two ends of this path. So after the first.py, add a double quotation, and before the C drive, add another quotation. You have to move your keyboard. Yeah, great. Okay. So we basically tell our shell that that's the path. Okay. So see, this is a different way of using Python. Instead of going directly inside the interpreter, we write our application somewhere else, and then we tell Python, hey, go read that file and execute it.
All right.
Does it make sense?
It does. And so if I change this, and I say like,
just hit up. No.
Oh, I need to save it, I guess.
Let me yeah, you need, yeah, obviously you have to save it. Just hit Control S, yeah, and then up, enter.
Yay.
Great. Okay. So, and that's one of the things that you see that you could, so stuff like Pyrevit kind of provides that in Revit environment. You have a script somewhere that you can make changes to, and every time you click on the button inside the Revit interface, it executes that script for you again. It's the same concept, right? You don't have to compile like other languages and create an .exe and run it somewhere else and all that kind of stuff. This is how easy Python is. You just change your script and give it to Python, and it would run it again for you. Right, and we'll talk about why this is sort of like simpler than other programming languages and stuff later. So let's write our first application.
Okay.
Let's write a application that I've put in here. Everybody can copy this.
We're gonna go back to your screen.
Oh yeah. Sorry, I thought that I have it. Okay, so I put this out. Like the final program right here, but we're gonna type it line by line right here. And this application, what it does is that it's the standard Python example. It prints the Fibonacci numbers from in the range that we basically give it to, starting from 1 and then up to a value. So what we're gonna do is that we're gonna start with setting a series of base variables that we're gonna need. We're gonna put 0 in A, and we're gonna put 1 in B. Right? Save.
Mm-hmm.
We're good to go up to this far. We're not going to test that application right now because as you're writing program, you kind of get better. You understand that you don't need to test this. You know it works, right? Okay. So when we talked about the algorithm, you remember we talked about the concept of branching and looping. One of the instructions in Python that creates a loop block for you is called while. And see, as I'm typing it, my environment changes the color to purple, telling you that that's a reserved key. It's a reserved name in your application, right? This creates a sort of like a while block. It's a loop that loops until a condition is met. The condition is A less than 10, right?
Okay.
So you can just read it as English. While A is less than 10, and then we're going to add a colon at the end. And this starts a block in Python. So when I said enter, see, Visual Studio Code automatically puts 4 spaces and goes inside, right? Here's where you learn that Python uses indentation to show blocks, right? And we'll get into the details of this later on in the next session. We will start talking about the blocks and their scopes and all that kind of stuff. But whatever we write here after this, I'm gonna just put some characters in here. Whatever instructions that we type in here are going to be part of the while block, right? And you can see that black line in here, and you can see the indentation. So every time while loops, it re-executes the instructions right under it, right? They belong to that block. Now, let's say we're not going to write the actual application. We're just going to say print A as our instruction, right? Now let's run it and see what happens.
Save it and then run it.
Yeah.
Whoa. Go on.
At some point, you have to hit Control C. Otherwise, this application will run forever until your computer is run out of battery or the world dies or something like that. Right? Why? Okay. Because that condition that we put in there is never met. It's never broken, basically, right? A is always less than 10. Why? Why is that?
Because it's 0.
Yeah, because it's 0. 0 is always less than 10. So it never really comes out of that loop. It never breaks this condition, right? So what we're going to do is we're going to say A equals A plus 1. So let's add 1 to A every time and then print that.
Can I? Yeah, I can add lines between lines in Visual Studio, which is nice. Okay. So.
Does this make sense now?
Huh?
Does this part make sense now?
Yes.
See, it takes the value of A, adds it to 1, and then puts it in A again.
Okay.
and then it prints it. And you
So
can
now
see
I get 1 through 10.
1 through 10. Why? Because the value of 0 was 1, the value of A was 0. We entered the loop, checked the condition's okay, it's a pass. And then we add 1 to A and we print it and we loop from there, right?
And then as soon as it hits 10, it breaks the condition and stops.
Exactly. As soon as it hits 10, it breaks the condition because the 10 is not less than 10. Now, if you want to do that too, we can say less than or equal to 10. This is a different operator. They come together. You can't type them. You can't type them like this, right? Type them like that. That's it. Equal, less than or equal. So if we do this, we're gonna get it 11 too. Right? Or we can change the number to do anything else. But let's keep it at 10. And then we're gonna type the rest of the program that we wrote. We're gonna have print A, and then we're gonna say A equals B, and then B equals B plus A. So if you know about the Fibonacci numbers, like each one of them is the sum of the two previous ones. And the way we do this is the algorithm that we follow to calculate the Fibonacci numbers, right? This is called the algorithm, the method that we are trying to do. So we put 0 and 1, and then we're gonna print A as our 0, and then we're gonna move 1 into A, which is B into A, and then we're gonna change the value of B and add A to it, right?
Okay.
And then we loop over again, and we loop over again, and we loop over again. I don't want to get into too much about the algorithm and stuff like that. Algorithm is, we usually don't deal with this kind of stuff. For like your work, well, the stuff that we deal with Revit is most of the time is pretty simple to understand what we are trying to do. Hey, we want to iterate over like 50 different doors and change the property value to something else. Like a lot of times it's like that. But I understand that like a mathematician can come up with a different, more efficient algorithm to calculate this, right? Calculate the prime numbers, for example, or calculate the factorial of something. There are different. This is called an algorithm, and everybody.
I feel like this is when, or maybe it's looping, when you need to look at a list rather than a single element. No.
No, algorithm applies everywhere, because like in this algorithm for this specific problem, we need to use a loop, right? Maybe somebody else comes up with an algorithm that doesn't use a loop. I don't know, right? You could write this as a flat program, right? That goes from prints like 1, 2, 3, 4, whatever the Fibonacci numbers are, and doesn't calculate them. But it's not very extensible, and it's not very efficient, right? Maybe it's even more efficient. Maybe if it's for efficiency, you go down to the hard-coded sort of like just print the numbers. I don't want you to calculate it. But that's the concept of algorithm. That's the way you decide to do something. And we'll talk about this stuff in the future. That like what criteria helps you decide to go in either direction. Use a more complex algorithm, use the one that is faster and uses less memory, or use the one that uses more memory but it's not as fast. That kind of stuff. Right? So it changes the way you provide the instructions. The results are always the same, but the algorithm might be different, right? One last thing to compare, and then you can, so we save it and run it. And then we get 0, 1, 2, 4, 8. Let's change that to 100 and then run it again. We get 0, 1, 2, 4, 8, 16, 32, 64, right? Did I type it correctly? Okay, so one last thing that I wanted to show you. Jesus, I'm going. Okay, so you see I'm using a different notation in here on these two lines. This is a Python convention that helps you sort of like reduce the number of lines that you have, right? So instead of saying A equals 0 and B equals 0, I can say A and B and then equals 0 and 1. So the 0 goes inside A, 1 goes inside B. So the same sort of like pair of stuff that I have here will be paired to the stuff that we have on this side.
Okay.
Does that make sense?
Yes.
This side.
So you condense it to a single line rather than.
This is just a single line. And then you can do the exact same thing in here. So A will be B, and then B will be B plus A, right? So Python has a little bit of stuff like this. Every once in a while, you want something that's a little weird. We get into like weird things that we can automatically generate lists and stuff like that called list comprehensions. I'll show you examples of this as we gonna play with Python in Revit, and sort of like you get familiar with these little Python things. Obviously, the goal of this session is not to teach you everything about Python. It's about teaching you enough so it can be dangerous. And then you can go and look up the stuff that you want to do and play with. How are you feeling?
I'm feeling pretty good.
Okay. You write your first Python application, right?
Yeah. I just wrote an application that says Ehsan is so great.
Okay. Timon, how are you doing on time?
We have 13 minutes left.
Okay, let's talk about the basics of computer science, the computer architecture. Okay.
Let's do it.
Really quickly, I want to give you a little bit of an introduction in the computer architecture, because knowing this is really important. It was really important to me because when you first approach programming, it's something that's really scary to you. I'm like, oh, I don't really understand how these machines work, right? We're going to build slowly from these theoretical concepts, and as we go through, I'll explain more and more and more, and as you learn Python a little bit more. So today we're going to talk about Charles Babbage and Ada Lovelace. Charles Babbage was a rich guy. He would invite his friends and stuff like that, and he would create these complex mechanical machines. One of them is called the difference engine and then the analytical engine. Actually, let me search analytical engine, Charles Babbage. Oops, I mistyped it. So it was like a complex mechanical machine like this that pretty much would do like math, right? Just add numbers and calculate the differences and all that. It's like basic mathematics stuff, right? He had a friend that her name was Ada Lovelace, the Countess of Lovelace. We call it Lady Ada. She's credited as to be the first computer programmer. She's the person that worked with Charles Babbage and sort of like came up with this idea that, hey, this machine that you're creating, it actually can do a lot more. We can make it generic and we can instructions and it can do anything, right? So she's the first one that's been credited with coming up with, hey, we can program these things. Before that, the term program really didn't have a meaning like this, right? And then on the computer architecture, we're gonna know this person, genius polymath, John von Neumann. He is the one that's credited with coming up with the standard architecture of the machines that we're using today. It's very simple. I don't know. I should have Neumann machine. I should have grabbed an image of this, but I completely forgot. Okay, so this is the architecture that he suggested that the modern computers should use. We're gonna have on the main piece, we're gonna have the machine. Inside of the machine, we're going to have a piece that's called a central processing unit, a CPU, and we're going to have a whole bunch of memory, right? We're going to have a series of input devices, and we're going to have a series of output devices, right? These sort of like devices will talk to each other on, I'm sorry, I should have, let me see if I know that, oh yeah, hold on. Let me grab one of my notes. This is my bad. I should have prepared this piece, but I completely forgot. Okay, look at this one. These are the notes for another class. Look at this image, right? We have the CPU. We have that little machine that's usually our motherboard that hosts all these different pieces on it. We have a lot of memory on our machine, right? There's a thing that connects these two together. It's called a data bus. There's actually more than this, but like very, very talking about concepts. That's how CPU communicates with memory and the input or output devices, right? All of them are sitting on something that we call a data or an address bus, like two different buses. But that's how CPU communicates. We call it bus because data flows through this line. Right? So when CPU wants something from memory, it sets the location of that memory on the address bus, and the address bus is connected directly to memory, right? The memory chips, and the memory reads that value and reads the value of that memory location and puts it on the data bus. And CPU is also sitting on the data bus, so it receives that data. That's how they communicate with each other. This is exactly how your CPU communicates with all the other pieces. the USB stick that you connect to your computer, all the other input and output devices. Even your monitor has a piece in the memory that the CPU or the GPU read and write to, and the monitor and your display adapter will show stuff on the actual monitor, right? Now, there's a lot of abstraction happening inside this, but at the core concept, this is how a computer works. I want to show you a really, really simple example of this. Let me see if I can find my video feed. I don't know if you can see this or not. Can you see this in your screen?
Yeah.
Okay, so the top part, don't worry about the top part, and don't worry about the bottom part. Just a little piece in the middle. You can see that's a CPU.
Maybe can you stop sharing your screen so I can see it a little better?
Let's do this so I can see my own screen.
Awesome. Okay, perfect.
So this is a CPU. This is called a MOS 6502. This is the CPU that we all enjoyed playing Ataris and the first Apple computers and stuff.
I didn't play on the first Apple computer.
It's a very, very simple CPU that just executes instructions. This is called a non-volatile memory. It's like your hard drive. You store stuff on it, but when you cut the power from it, it doesn't delete the contents. This is called a volatile memory. It's like your computer RAM. You store something to it, but when you cut the power, it'll all go away, right? And you can see all these wires like going between these back and two. These are the address bus and the data bus. That's how they connect to each other. This is a real full computer, right? This little thing is a full computer. It does anything that your computer, it theoretically can do anything that your computer can do. Like it's got a little display at the bottom. I haven't finished this part and stuff like that. But it's a computer that we're using every day is really as simple as this. Every other extra stuff that you see around it is because of standards and how things are supposed to work and the speeds and all that kind of like this other stuff around this technology that we want to make sure it works. Like, for example, all these ports that you have, USB ports that you have on your machine, actually go to a single processor, mini processor that handles communication between all the CPU devices. So your CPU, so it frees up your CPU to do other stuff, right? So we see a lot of complexity in this that way. But as you're thinking about writing a program, always remember that your instructions are going to go on this tape. They're going to get stored in the memory. You're going to use memory for a whole bunch of other stuff, store variables and lists and dictionaries and all that kind of stuff. And your CPU has a counter, has that head that's going to go on each one of these instructions one by and execute those, right? Now, when you ask Revit to do something for you, Revit is just another tape. And it has a whole bunch of other instructions on it. So when you tell Revit, hey, give me the number of walls that you have inside the model, it's going to go jump into Revit's tape, and it's going to run a whole bunch of instructions there, which the Revit programs have written for us, and it's going to get the value and return it to us. The only thing we have to make sure is that these two tapes, they can communicate with each other, right? I think that's all I had for this session. There's a lot of information I know, and we moved through it really quickly. But again, the purpose of this is for us to get familiar with Python enough. So on the next session, we can actually start playing with some Revit API and touch a few things here and there. And I'll give you enough resources so you can dig in deeper and learn the sort of like the concept that you are familiar with. You sort of like here, like you want to know everything about the sets. Now you know what kind of a set is, so you can look it up, learn about how sets work and all that kind of stuff.
I think that's an awesome introduction.
I'm on video now. Hopefully people can hear me. Thank you. That was really cool. 2 hours solid. I just wanted to speak to everyone who's still out there. Thanks for sticking with us at the beginning when we had some bumps and all. I see you're getting some good kudos there. I hope you're watching the YouTube stream.
I have not. I'm actually going to right now. I kept it.
Definitely give him kudos on there. Subscribe if you want to be seeing these things. Share about this. We are going to be doing 3 more of these at least right now, prepackaged.
Yeah.
Is that right?
Yeah. 3 are planned.
And I assume that the 63 people who right now are concurrent viewers, these are the committed folks. So you guys are the ones who are really in for this for the next 4 sessions, and we want to support you the best that we can. Yeah, we can hang out here, or we can end the stream. I don't know if there's any questions or anything we might want to answer live for a few minutes. We could probably just sit here. We'll just cut this off when we.
Yeah. I was gonna ask Dana, like, Because like this is some like tell me how give me feedback, like how was it, how do you want it to make it better? Do you like this computer architecture, computer history stuff in the conversation?
No, I like it. I think all of it was a really wonderful foundation.
Okay.
I wish we would have done a Dynamo workshop first, though, so that I could have you as an expert in Dynamo so that we could make some of these translations a little bit better.
What are we going to banter about then?
It's true.
See, this is like there's a very clear contrast lines in here. Mac OS, Windows,
This is why we're such great friends.
Rhino, Revit, you know.
I still haven't gotten my Rhino shirt, by the way.
Yes, that's on me.
Well, thank you guys all for joining us. As you know, this is obviously the first workshop. Thank you so much, Your Desk and Timon, for hosting it and kind of, messing through and fudging through all of this with us. But we would definitely appreciate any feedback in the Slack channel after the fact if it comes to you. But of course, I know I'm very excited for the next 3 sessions. I hope you guys are as well. So thank you all for joining.